Hello, everyone, and welcome back to Manufacturing Mavericks, a YouTube series where we talk with product experts about the neat technology they bring to the manufacturing industry and how it can help benefit shops like yours. Before we get into today's episode, be sure to like this video, comment, and hit that subscribe button to support the HEH Group YouTube channel. So without further ado, I want to introduce our guest for today, Dale Fleck with Mazak MegaStir. Dale, thank you so much for being on.
Oh, yeah, you're welcome. Thank you for taking the time. It's great.
Absolutely. Yeah, so Dale, why don't you tell us a little bit about yourself and then go into the history of Mazak MegaStir?
Sure, Shae. Sure. I've been the general manager for Mazak MegaStir for over a decade. I've been in manufacturing engineering for over 30 years. I started off at Texas A&M, in the Southeast Conference, and so at the time it was, the conference changed a little bit, but yeah, that's where I got my start in engineering. So, yeah, I've been doing this for a little while.
So were you a Johnny Manziel fan or
Oh, of course, Heisman Trophy winner Johnny Manziel, graduate from Texas A&M, born and bred Texan. Hey, you can't go wrong with that.
can't go wrong with that. Then our boy Baker came through and you know, I love Baker, but anyways, back to manufacturing. Always got to throw a little football in there.
Yeah,
So with Mazak Megastar, tell us a little bit about what you guys do. So when we are talking on manufacturing Mavericks, we like to act like nobody has any idea what we're talking about, because like sometimes people are so wrapped up in like the CNC world that when we talk about like EDMs, they're like, "Whoa, I never even heard of that," or maybe they're so wrapped up in like inspection that when we talk about five axis, they're like, oh, like, it's new to them. So why don't you give us a little bit of history on Mazak Megastir and what it actually is that you guys are doing?
sure, Shay. And it makes sense. I think that friction stir welding is an interesting topic because some people do know it well and understand the simplicity of it, and other people have, they're just not familiar with it. So it's nice to take a little bit of time. The technology that we work with is called friction stir welding. It's simply just joining. And the value of joining with friction stir welding is that it's done in a solid form, and so you don't melt any metal, and so you don't have any porosity or any of the negative aspects that go with melting metal. Furthermore, it's green technology, so there's no arc sparks, there's no fumes. What we've done here at Mazak and at our division, Mazak MegaStir, is that we've incorporated friction stir welding on your standard milling machines. So you can put friction stir welding as a tool changeout on any of your milling or vertical horizontals, your Integrex multitasking machines. And what it really does is it consolidates your shop floor. It reduces your footprint. Then how much your part needs to move. It's just part stays on the machine, and then you move the tools to address it. That's what we're doing here.
And I know
Oh,
you have a video. Would you want to pull that video up to
oh,
show?
yeah. And just before I start the video, this is what you'll see Mazak's Megastir's patented tool holder. This tool holder is an intelligent tool holder. Communicates via wireless Bluetooth back to the controller in a closed loop system that will adjust loads and your feedback of position control and things like that. So it's constantly talking to the machine and talking to the operator through the HMI interface on the smooth controller that Mazak has on every machine. So here we go.
Awesome.
So this video is showing that it's a pretty simple process. You just plunge it into the material, and what we have here is we have a plate that, or I should say, we have an ingot of metal that we machined out. We have features inside that metal, and then we put a sheet metal plate on top of it. We're just stirring that in. what they call a butt lap joint, where the plate just sits on to the machine surface that's recessed into that base material. This is a standard aluminum. It's a 6061 block of metal that we machined conduit features and flow channel features in. And then the top material is also 6061. It's just a aluminum sheet metal. And so the stir process is pretty innocuous. You can see there's no real chips flying around, and there's no fumes, there's no arcs or sparks. We just we just stir the metal together and it bonds. And so this is the finished product. You can see it's pretty smooth. If you want to come back through and deck that material, you can. And then if you do that as a deburr or second pass decking, you can't even see that the material was bonded. It looks like just a block of metal when you're done. But the value is that you've got complexity that's inside that metal now that you wouldn't be able to achieve any other way.
That was a super interesting video. I would watch some of your guys' videos and stuff on YouTube, but I thought that was really neat because it also did it very quick. And I don't know a ton about welding, but I feel like that was pretty fast.
Yes. So it's interesting that everybody thinks, the welding process is a laborious process in your fabrication of a part. But really, the way that we've integrated this, it's extremely low cost. It's the price of tooling, right? And then it also is it's extremely fast because you don't have to move the part off the machine and do another setup. It's a repeatable process, so there's no scrap. There's no waste. There's no, you don't have a welder sneeze and you have to scrap a part and redo it. So. But because it's all on machine and it's repeatable, you have a lot of value there. And to your point, though, Shae, it's fast. We're actually Mazak's setting records as far as how fast you can friction stir weld. I'm going to present a paper on 10 meters a minute here
Wow.
in a few weeks. So 10 meters a minute is faster than arc welding. It's by far. It's faster than automated MIG welding. It's faster than laser welding. If you try to laser weld it, I think the fastest that I've heard is maybe 8 meters a minute. So we're well beyond that. So it is your fastest process. It's on machine. There's no additional setups, and it's clean and green. So.
That's amazing. And so with the friction stir welding, I think the tool holder is super neat. I have one sitting behind me right here for those of you guys that can see it.
Everybody should have one.
Yes,
Sitting at your desk, right?
I agree. Everybody needs one. But where does this type of product fit in the market? So we have the defense industry, we have medical, we have automotive, we have aerospace. There's so many different industries. Where are you guys seeing friction stir welding and these types of tool holders be useful? And are you seeing people get into it more because it's as easy as a tool change?
I think that we're making it easy enough for anybody to adopt the technology. You asked a question, but I'm actually going to step back for a second and just say that I think that manufacturing is a pretty broad category. Anything under roof is considered manufacturing, whether you're cutting chips or laser cutting out, fabbing parts by laser jet. But what the way I see this technology being utilized is that it's essentially an assembly process, and so anywhere that you have assembly, you can do that on machine, and so it applies to defense, it applies to rail car, it applies to to the EV industry. It applies to electronics. So it really, anything that you take apart, a precision part, and then the next step or next operation is assembly, then this is an ideal solution. So, but we started off, originally this technology started off in universities, and then it moved to defense, because defense is often an early adopter of technology, and also, in the early stages of technology, the prices of leveraging technology is high. And then it went into space, and so about 25 years ago, NASA, used it for the Delta IV rockets and things like that. So it became a common a solution for joining and assembly, and space exploration, and Blue Origin uses it, SpaceX uses it. It's just commonplace in privatized space exploration. Now what you see companies like companies that are in the electronics business, and semiconductor business, AI chips. They all are using friction stir welding to join their electronic components. It's great for hermetic sealing. So if you're in a harsh environment, or you just don't want any liquids or contaminants getting in, it's a great solution there. It's also great for cooling plates or heat exchangers if you want to control fluids inside your component. So it's it has a tremendous amount of applications, and it's very versatile technology. Really comes down to if you're cutting chips and then you are trying to assemble parts.
Assemble something.
In a manufacturing environment, it's an ideal solution.
And with, have you guys always only had the tool changer product, or were you guys friction stir welding using other methods and then turned it into the tool holder once you partnered with Mazak?
We've been doing this for 20 years. I've been in charge of this group for about 15 years, but we've been performing friction stir welding for 20 years. We have a patent that we originally filed for a tool like this, similar to this. It's a PCBN tool, polycrystalline cubic boron nitride. It's the type of tool material that you use for friction stir welding in steels and Inconels and more in heavy metals like that. We use diamond tooling, which this is PCD, or it's synthetic diamond. It's the hardest manufactured material, or synthetic material available. We use that for joining softer materials like any of the aluminum grades or copper, bronze, that kind of thing. But we got our start by making tools. That's how we got into the business. We worked with the government to develop the tool material and then patent it, and we decided that it's a material that makes sense for us to, and it's a technology that makes sense for us to start a business and offer this to a broader group of people, and that's kind of how we got our start, and that's why we've been in this business for a while. We came up with the instrument and tool holder, also known as the intelligent tool holder. We came up with that as a way to cheaply integrate the technology that Mazak offers from a subtractive standpoint to the friction stir welding and the man tech associated with joining, and so that was the whole idea behind the tool holder. And we wanted to do it so that the machine was not a dedicated machine. And a lot of solutions out there is they'll build a machine specifically for friction stir welding. That's cost prohibitive. They also do an adaptation on an existing machine that makes it a dedicated machine for friction stir welding. Again, that's cost prohibitive. You really want to be able to align your operation with a tool change out, and that's kind of what we've done here.
Yeah, I mean, what a genius and flexible idea, right? Customer buys a machine, maybe they do some welding at their shop, or they're looking to get into parts that require that type of assembly at the end. And now all of a sudden they buy one machine, and with a cost effective solution, they can have two purposes to one machine. So I think that's really great, especially that you guys have kept it, you know, the cost wise to get into this, the barrier to entry is pretty low, and that I'm sure is very appreciated by customers who get into this. And so, with customers that get into friction stir welding, what type of capabilities, should they be expected to do from a part standpoint? So, say a customer decides to get to the tool holder, what types of parts can they now do because they have the capability of the friction stir welding tool holder?
Yeah, as far as entry into market, I think that's a good question. A lot of people kind of struggle with is that if I adopt this technology, how is that going to give me more opportunities or a broader spectrum of manufacturing that I can offer. And so what I think that I try to advise people on is that you really shouldn't be looking outward. You should be looking inward. And what I mean by that is that you already have all those operations in your facility. I mean, if you go to any large manufacturing facility or any job shop, the scale doesn't matter. The recipe is the same. You have raw material come in. You do precision machining. You do inspection on those precision machine parts. Then you move it over to assembly. You complete that assembly to have a finished application. Then you go inspect that, and then you ship it out the door. It's the same thing. That's manufacturing, right?
Right.
So when you look inward and you say, how can I leverage this technology? You just have to look from the precision machine section of your building over to the assembly section of your building and say, I want to integrate all of these and put it all on one machine. And that's really where you get your value. You get your value in the efficiencies and the proficiency associated with the technology. So you're bringing the efficiency is you're not moving that part over to another area. You're not having to set it up again. The value there is that you can go from precision machining straight over to precision joining, and that's really where you see your savings, and that turns into cost savings, right? You can move more parts through. So what you've done is, depending on, it doesn't matter how fast you friction stir weld. Yeah, we can go fast. But where you get your real cost savings is not in the speed of the weld, but in the elimination of wasted movement of those parts and the amount of time that you save from the time that raw material comes into your door to the time that you have a part going out the door.
Right, just eliminating those secondary operations is where you're going to
Exactly.
see
Yeah.
a lot of that savings. And I'm sure from an accuracy standpoint as well, not picking up the part and moving it somewhere else. I know when it comes to like 5-axis machining, we're always talking about that. Like, oh, you can keep the part on the same machine. You don't have to move it. You're going to reduce, any error or being off in tolerance or something. Is that the same for welding?
Yeah, undoubtedly. Yeah. So it is the most precise process because it is a repeatable machine process, and we can dial it into the micron, and that's the difference. I mean, when you are melting metal, whether it's manual or automated, you can't dial in that precision. So I have pin tools here. I can show you a couple of them. So
Yeah,
so
please.
here's a standard coated pin tool. We use tool steel and then we coat it to give it extra strength. And this pin tool is great for development, but you can see the size of the pin, right? I mean, that's a pretty broad, wide weld.
Mhm.
But at the same time, we have this pin tool, which is smaller. It's still 4 millimeters in depth, but you can see we can dial in the size and and width of the of the effective end of our tooling, so that we can get a precise width of weld, a precise depth of weld, and so you can really um, increase your precision on joining. Not you know not to say that the repeatability really is the saving grace here, but as far as precision goes, we do have a lot more flexibility and precision with this technology.
Sure, and I think you had a couple slides that you wanted to share, so I do want to give you some time to pull those up.
Yeah.
Just while you are pulling those up, I just think this is super neat technology. Everybody listening, these types of conversations are really meant for you to understand what is out there for you to invest in to be able to bring up the capabilities of your shop. And I think something like this friction stir welding, maybe it's something that you haven't thought about in the past, but maybe it's something you're thinking about now. Maybe you know a process in your head that could benefit from this. So be sure to reach out to Dale and his team to get some more information on this type of technology and just really learn and always know what's out there. But Dale, sorry, go ahead and let's run through these slides.
Okay. Yeah, Shay. I mean, we've covered a lot. You've had some great questions, and we've covered a lot of material already. But to take a step back and walk through this presentation, um, I, uh, I've got some information that I think would be beneficial for everybody to see. As I mentioned, friction stir welding's been around for 30 years. We started friction stir welding in in 2001. We being Mazak MegaStir started friction stir welding in 2001, doing heavy metal joining. You can see on this picture, this is friction stir welding in stainless steel pipe. And so the tool gets pretty hot. That's why we used PCBN, polycrystalline cubic boron nitride, as the tool material. Friction stir welding is a pretty simple process. All you do is plunge a hard material into a less hard material, and then you rotate that tool. And what that does is that plastically deforms the material, that your workpiece material, and when it reconsolidates, it consolidates as one solid piece. It's the same process that you use for forging. So you can see here what we use is we're using diamond tooling, plunging it into aluminum, and then we're stirring that at a relatively fast RPM, about 2,000 rotations per minute. And then we're traversing, as I said, anywhere from 6 to 10 meters a minute, to consolidate that weld. The materials you can join, are metals, refractory metals. We've got you can join steel, copper, nickel. You can also join these materials to each other, so you can join copper to aluminum. You can join steel to Inconel. It's a pretty robust process from that standpoint. All of the aluminums, I think this is a great application across the board, because you can join a 7,000 series aluminum to a 5,000, 5,000 to a 6, a 6,000 to a 2,000. So a lot of flexibility there.
Awesome.
I did want to show you a quick slide on production efficiencies. We kind of talked about that, and we talked about how there's no additional setups and the elimination of scrap and rework. We call this zero step, because the operator doesn't really have to move. The part stays in one place. The part doesn't have to move. It's just the tools move for you. Mazak offers this as what we call a hybrid multitasking machine, and it really is just an option that you add to any of your Mazaks. You can add this option to a brand new Mazak if you want to buy one of our new EZ VCs, or you can add this to an existing machine if you already have, let's say, a VTC 300 sitting on your floor. You can add this as an aftermarket kit, but that is, we try to offer as much flexibility, but it really is just an option that goes on to your Mazak verticals, horizontals, or your integresses. This
Okay.
the product is it's software, the closed loop software that we load onto the machine. We add some additional hardware to that machine, and then we have the tool holder that comes with it that has the intelligence that communicates back to that closed loop friction stir welding process control.
Now, with the after kit market or the aftermarket kit, is that something that Mazak MegaStir will come out and put on customers' existing machines, or is this something that they are able to do themselves?
We assist. I mean, Mazak's known for our service, and we pride ourselves on saying that once we've sold a machine to a company, we become a lifelong partner, and so we try to support with our application engineers, and we try to support existing customers with our service, and it's the same thing with the aftermarket kit. The machines are on the customer shop floor, but they're supported by the service team, and we'll go out and we'll do the install for you.
Okay. Okay. Makes sense. Now we have a couple minutes left here. Was there one more slide that you wanted to get to?
There wasn't. I think that kind of covers it. I just wanted to make sure that we talked briefly on some of the details, and you kind of had a chance to see that. But,
Yeah.
if we have time, I would like to possibly talk a little bit about the diamond tooling, because I think that really takes this whole system and solution to the next level.
Yeah, let's go ahead and cover the diamond tooling, and then I would like to have you back on again on the podcast to then expand even more on the different things that you guys offer. So maybe kind of give a preview of the diamond tooling, and then we can have a whole other episode on it where everyone can learn about that.
All right. Well, so yeah, talking about the diamond tools, I think this is a great segue from the hybrid Mazak platforms to diamond tooling. Um, it, we over at Mazak MegaStir patented solid diamond tips for friction stir welding. It's something that we've known for a long time. It has a lot of value, and really did some development work to make it a commercial solution. What it does is it gives you tool life that is about 150 times greater performance than the standard tool life. So I told you about tool steel tools.
Yeah.
These pin tips, these tool steel tools. We make the same tool with a diamond pin tip, so you can see the configuration is about the same, but it has a diamond tool tip, and what that means is that you don't have to do any redressing or you don't have to change out your tooling. It's a non-consumable. So
Okay.
so unlike traditional milling and subtractive operations, you have to change out your tools as they wear out over time.
Mm-hmm.
When you use diamond tools, they really don't wear out. So this process becomes a non-consumable process. It's just you do the tool change out, you keep your tool holder with that design tool tip in your machine, and you just you recall at any time that you need to join parts. So it's that simple. So it really it's the next level of progression. We're always trying to change the game and add value to our customers, and so this is just another example of us continuing to innovate and continuing to offer great technology for the Mazak customer set.
Yeah, I mean, look at that chart. That shows it for sure, huh? How much,
Oh yeah, yeah. The
you know.
blue is the traditional tool. You gotta look close to find it, but yeah,
Yeah,
yeah. That's
I was
your
like really close up on the screen. I'm like, what are we even?
what are we looking at? Yeah, I'm sorry.
That
Yeah,
is
yeah. The
impressive.
blue is the tool performance of a traditional tool. So yeah, the orange is the life expectancy of a diamond tool.
That's awesome. And I know that someone would ask this question. So like the life expectancy of the diamond tool, I am sure outweighs the cost of the diamond tool, right? So like
Oh, yeah. Yeah, for sure. So it's about 5 times more expensive, but you get 150 times more performance. So that's the math, right?
so
So
the return is
yeah, is significant. And again, I mean, we're trying to offer solutions for the customer, and so we're not trying to price match performance to cost.
sure.
We're offering a solution that makes sense, and it just turns out that it's 5 times more, but the performance is 150 times more. So it
Yes.
just
So
it works out. It definitely works out in the customer's benefit, and that's kind of why we look for these opportunities to offer the customer something that really gives them a competitive advantage.
yeah, that's fantastic. That the benefits just totally outweigh any type of cost that may be associated. So that's great. Well, Dale,
Yeah.
thank you so much for being with us. Is there any last few things that you'd like to share?
No, Shae, I appreciate the time. I appreciate the opportunity to sit down and talk to you and talk to your audience about what we can offer. I love this technology. I think it just makes sense, and so I'd love to talk to anybody one on one, help them walk them through the process of adopting it. It's pretty simple. But
Absolutely. And
yeah.
what about trade shows this year? I think you guys are going to be at IMTS, right?
Oh, of course. Yeah. So we'll be at IMTS. We'll be in the Mazak booth, and so yeah, come out to IMTS. That's probably the next big event. And so yeah, we'd love to talk to you.
And then lastly, if there is somebody that does want to get in touch with you, how should they reach you in Mazak Megaster?
Yeah, we have our information out on the World Wide Web, right? We've got it. We've got. You can go to our website, which is the www.mazakmegaStir.com. You can go to Mazak's website, which is www.mazak.com. So either way, you can reach out and get through to us through the internet.
Great. And we'll be sure to put your website link and your contact information in the description. So anybody that may want to reach you to ask some questions, they can. And everybody, thank you guys so much for listening. We hope that you enjoyed this episode with Dale and Mazak Megaster. And if you have any questions, please be sure to reach out to Dale or someone here at the HEH group, and we'd be happy to get you in touch. Thanks for watching, and we'll see you next time.